All right, let's do some acceleration calculation. We'll do some practice here with this. It says at the top of the screen here, a class of physical science students wanted to study the motion of a person as he or she slides down a water slide. The water slide has one section that is like a ramp and another section that is flat. The students marked off the entire slide at 2-meter intervals and measured the time as the person passed each mark. The time and position were used to calculate the person's velocity or speed. Calculate the acceleration of the person on the ramp and on the flat section of the slide. The student was on the ramp of the slide for a total of 5.94 seconds, so there's your time. At the top of the ramp, his velocity was 0 meters per second. At the bottom of the ramp, his velocity or speed was 10.10 meters per second. What was his acceleration while on the ramp of the slide? First things first, what are we being asked to do, right? We're asked to calculate acceleration. That acceleration is equal to the final velocity minus the initial velocity or speed divided by the time, right? So if I plug in my final velocity, which was 10.10 meters per second, minus my initial velocity, which was, or his initial velocity, which was 0 meters per second, divide that by the time it took to go from 0 to 10.10 meters per second. So it took 5.94 seconds to do that. If I do that math, I end up with 10.10 meters per second, that number right there, minus 0 meters per second. So that would be 10.10 meters per second. Divide that by the 5.94 seconds. And if I do that math, so 10.10 divided by 5.94, I get 1.70 meters per second squared, right? Because my seconds don't cancel here. So it's meters per second squared. So that means, that means every second that goes by, right? Or every second that goes by, this person changed their speed or increased their speed by 1.70 meters per second. The question that they ask or present is, the student traveled the full length of the flat section of the slide in 0.99 seconds. At the beginning of the flat section, his velocity was 10.10 meters per second. At the end of the flat section, his velocity was 10.10 meters per second. What was his acceleration while on the flat section of the slide? Now, obviously, I think we could probably look at this and intuitively know that the answer is 0 meters per second. But let's take a look at the solution. So we know that acceleration is equal to the final velocity minus the initial velocity or speed. Just put the speed number in there, divided by the time it took to make that change. So if we plug in the 10.1 meters per second, right? So at the beginning, he was going 10.1 meters per second. So there it is, this one, 10.1 meters per second. And at the end of the flat section, his velocity was 10.1 meters per second. So here's the end, right? Final minus initial. So here's the initial velocity. Here's the final velocity. Do that math, you end up with 0, right? 10.1 minus 10.1 is going to be 0. And so your answer essentially is going to be 0 meters per second. Now the question is, what's happening here? What you should ask yourself, was the student accelerating on the ramp or the flat section of the slide? And the student was only accelerating while on the ramp. So only while coming down the slide did the student go faster and faster and faster as they went down. But then once they got on the flat section of the slide, their acceleration, assuming there's no friction, right? Their acceleration stayed the same.